Assalamu alaikum. Welcome to Seval Ideas. So today we'll discuss about the characteristic strength of concrete. That what is the characteristic strength? Like, there normally we denote it by FCK. So what is FCK and how to derive it? And normally we have shown the concrete strength like M30, M25, or M20. So that magnitude like M20, M25 has Newton per mm square. So how to we achieve that strength on site or in a laboratory? So now we'll discuss about and detail and normally the definition of the characteristic strength of concrete as that if we have casted 100 cylinder or cubes of concrete and test it on an UTM machine, then only 5% or 5 cylinder will be failed and 95% will be passed that test. So that is the characteristics strength of that concrete if it is not fail by more than 5%. So that is the normal definition, but normal insight, never we have seen that 100 cubes have casted and tested to check that limit of concrete strength. So now we have to discuss about it and on the computer screen. So let's start. This is the general definition of characteristic strength of concrete. The strength of concrete specimen casted and tested as per given code of practice and cured for a period of about 28 days. And after 28 days, you to tested the samples, and 95% of the tested samples should not have value less than this. This means that if you have designed the concrete for M20, 20 Newton per mm square, M20 grade concrete, 25, or M30 grade concrete. So for which grade you have designed the concrete, and should that sample should not be failed. About only 95% should be passed and only 5% can be failed. So then that grade of concrete, then we can say that that is the characteristic strength of concrete. So this is the general formula for characteristic of concrete. So FCK is the characteristic strength of concrete, FM is the mean strength of concrete, minus K is the risk factor, and S is the standard deviation. We have discussed it in the next slide. So this is generally this is the strength of concrete probability curve. This is the probability curve of concrete. So this is the compressive strength, and this is the characteristic strength of concrete. So only this 5% of area of samples can be failed, and after that 95% should be passed of the samples. So this is the margin, and that is kept by the structure designer, which is, so this is the FCK. This value is the, so this is the general diagram or a graph for characteristic strength of concrete. So this is the bell shaped curve, and this is the compressive strength, and this is the specified characteristic strength of concrete. So this value, up to this value, this is the FCA. Main, this is the characteristic strength of concrete. We have discussed it here. So this is the FCK, and this 5% of the defective, this can be failed. It means that if we have costed about 100 cubes, and then only 95, so then 95% should be passed and only 5% can be failed. Sorry, I'm writing with a mouse, so that's why it cannot be perfect. So and this is the 5% effectiveness. It may be depend upon the design. It may be a 2%, 3%, or 10%. So this is we will discuss it in the next slide. So this is the case. This is the K 1.64. This is the risk factor, and this is the S standard deviation. We have discussed these values in the next slides. And so and this is the mean strength. This is the mean strength of concrete that normally we have to kept this margin from FCK to mean strength of concrete. So this is the margin that have to structure designers be considered while designing a structure. So and so in the next slide we have discussed the value of this. So normally we didn't cost about 100 cubes on sites, and we had just tested about 2 or 3 samples, and then tested that in the laboratory, and then we take average of that. But actually the case is not taking only the average, and so for that we have to take a samples of 1 to 5, 1 cubic meter of the concrete volume is 1 to 5 cubic meter. Then you have to take one samples mean 3 cubes or 3 cylinders, and from 6 to 15 cubic meter, and you have to take two samples mean 6 cubes, and beyond 16 to 30, and this is the 3 samples, 9 cubes, 31 to 50, 4 samples, 12 cubes, and 51 and above. You have to add four samples on additional on each 50 increment. Like for 50 you have to take 12 4 samples, and then after for 100 you have to take 8 samples. So this is the criteria for taking the samples and for the concrete cylinders. So cylinders, so this is the value of assumed standard values for the standard deviation. So this is the standard deviation. You have seen the case value. So the K is the risk factor, and this is the standard deviation. So this value is the about the standard deviation. So this is for different grades, like you can see here, and this is for M10 and 15 it is 3.5, and for M20 to 25 it is 4, and then for M30 to 55 it is 5 value. So this is about the standard code, and it is given in the standard design codes. So and after that we have discussed the risk factor. So risk factor is also different values, like for 1% defectives. If you were to like if 100 cubes, yeah, you want that only 1% of one cube should be failed, then that's you have to take these values, and after for 2.5 for defectives you have to take these values, and for this so in the case yeah, our case we have discussed here, this is the 5% defectives you have seen here. That's why we have take values of uh, uh, about 5, 1.64, sorry. So this is not a graph. 1.64 we have given this value because we have take the 5% defectives. Normally this value has taken and the designing, and after that, so this is the example that I have solved for you. So you can see here, so this is some of the columns. You can see you have to read it vertically like this, not horizontally. So this is the total, like this is the one sample we have tested, the 3 cylinders or 3 cubes as and the values, and it is the M20 20 grade concretes. So one cylinder gives us values of 23, and the other 20, sorry, 23, and the other 22, and the other 18. So these values are given by M20 grade of concrete, and take maximum of these values. So now this is the sum table. I want to understand that first this is the characteristic strength of concrete, and this is the uh, K and 2S you have studied there. So you have uh, this is equal to the mean strength. If we have convert this formula, you have taken this to the other side, then the equation becomes Fm equal to F. So this is the minus value. So this is equation will be become like this. You don't be confused in the equation. So this is the mean value of mean target value. So this is the characteristic strength plus 1.64 into 4. Why have you taken 4? Because yeah, you have seen that we have taken M20 grade concretes. For M20 it is 4. So this is the 4 and 20. This is the characteristic strength of concrete, and this is the 1.64 multiply 4, and this is 6.4. So this is the mean strength of concrete is 26.4. And the other steps you have to take characteristic strength plus 3. So 20 plus 3, 23. So you have to take the maximum. So maximum is 26.56. So you have to take that maximum values, and the other f average should be greater than f maximum. What is the maximum? Maximum mean this value. This is this value, and average is the average of all these three. So you have to take the average of these three values. Here you can see, and then you have to compare with the maximum, this maximum value, and if the result, if it satisfy this this relation, then it is okay, otherwise it is not okay. But in our case it is not okay, so that's why this is fail. In this column it is fail. Okay. And individual variation, minimum minus average, you have to take the minimum value. What is this mean? This is the minimum value of this column. You can see here you have another color. This is the main minimum value 18. So you have to take minimum minus average. What is the average value? Average values we have defined here. So this is the average, and multiply 100 divided by f average. So you have to and you have got the answer minus 15%, and um, a maximum minus f average. This is step 1, and this is step 2. Maximum minus f average divided by 100, and multiply 100 divided by f average. This is the same formula we have written here, and this so we have put the values. So maximum mean this values. First you have to take the minimum value 18, and then you have to take the maximum value 23. So this is the 8.4. So if your answer is plus minus 15, then it is okay. So in our case it is okay, because this is minus 15 and the other is 8.4. So this it lies in this range, so it is okay. And individual results, minimum into equal to greater than fck minus 3. So characteristic strength minus 3. So characteristic strength is 20 and minus 3, and you have got the answers 17, and minimum value you have seen here. This is the minimum value 18, and so 18 is greater than 17, so this is okay. But so this sample that we have taken here, like I have to show you. Yes, this sample that we have taken. So these samples that we have taken, M20 grade concrete, and this is failed because this value is not satisfied. So all these columns, if one values is not satisfied, then your test is not okay. So generally we on site we take just the average, but this is not the actual case. So you have to perform the test like this, that either it is okay or not. So I hope you will understand about the concept of the characteristics strength of concrete. If you have still any confusion in your mind, you can comment. I will explain for you. Thank you.